The key to solving related rates problems is to relate the rates of change that the problem gives you. That's all there is to it. But there are a couple steps. Before we can do this, we first need to identify all the rates of change. So I'm gonna write over here. Write this down. So, related rates steps. Okay, so what's the goal again with related rates problems? Right here. Relate the rates of change the problem gives you. Now, before we can do this, what do we need to do first? We first need to identify the rates of change. Identify all rates of change the problem gives and asks for. All right, let's go ahead and do that. So rates of change, we're gonna read this problem together. And we'll start with the first sentence. I'll give you a second to pause the video and let me know if anything is changing in this first sentence. And if the answer is yes, at what rate is it changing? All right, so pause the video, read the first sentence, and yeah. All right, what did you get? So, something is changing here. The volume is expanding. So what's changing? The volume. And what is the rate of change? Right here. Okay, so I'm gonna say V is the volume and rate of change. What's another word for rate of change? Derivative. So this is pretty important. Remember, rates of change, that's just another word for derivative. So yeah, this is a derivative, and I'm going to say it's dV, right, because it's the rate of change in which the volume is expanding. So the volume's changing with respect to time. So this is the volume. It's changing with respect to time. S stands for seconds, so that's time. So I'm going to say dV dt. All right, I'm going to give you a second to pause the video and let me know if there's another rate of change in the next sentence. Okay, what did you get? So something is changing. The radius is increasing, but they want us to find how quickly the radius is increasing. Let's read that again. Find how quickly. So determine the rate of change in which the radius is increasing. So rate of change. Okay, so radius I'm going to call r, and rate of change. So basically they're asking us to find dr dt, right? Volume, we got dv dt. Radius, we've got dr dt. Okay. So find dr dt when? When the balloon's diameter is 2 centimeters. So when d is equal to 2. In general, when working with word problems, the goal is to convert it into equations as quickly as you can. Working with equations in math is simpler than working with words. Okay, so that's step one. Step one was to identify all rates of change that the problem gives and asks for. So what did the problem give us? They gave us that dv dt was how much again? 2 pi cubic centimeters per second. All right, so that's what the problem gave us. What is it asking for? It's asking for dr dt. Dr dt, when again? When the diameter is 2. When the diameter is equal to 2. Okay. So you'll notice here that nowhere did they talk about the diameter. They talked about something that's pretty similar to the diameter though, and they're asking for its rate of change. So it makes sense to convert this, or try to get the radius from this. If the diameter is 2 for a sphere, okay, so let's draw this. So a sphere, if the diameter is 2, how long is the radius? The radius is going to be half of the diameter. So half times 2, which is 1. Okay, so we've identified all the rates of change that the problem gives and asks for. Okay, what else did we identify just now? They gave us some extra information about the radius. So I'll write a bullet point here. They may also give some information about the moments, right? The moments. More about that in a second. About the moment for where they want the rate of change. Okay, but yeah, this is super important. Identify all the rates of change the problem gives and asks for. They might give you some extra information here, and you might have to use it later. Um, okay. But what's the end goal again? What's the end goal again over here? Relate the rates of change the problem gives you. So, step 2. Actually, we already kind of did step 2 a little bit. Step 2 would be to draw a diagram. We just drew a sphere. But draw a diagram to help you relate the rates of change with an equation. Right? Like I said earlier, the goal, whenever in math, whenever you face a word problem, try to convert it into equations as quickly as you can. And you can do that with step 2. Draw a diagram to come up with the equation. Okay, so this is a sphere. Yeah, like a ball. Circular ball. And that's what spheres are. And okay. So it says the volume. So how much space this sphere takes up is expanding. So it's getting bigger. Okay. At what rate is it getting bigger? Right here. dV, change in volume, with respect to time. So I'll just write it here. dV dt is equal to 2. Yeah. And they want us to find what again? Determine how quickly the balloon's radius. So the radius, you start at the center, go to the edge. That's the radius. Like that. Determine how quickly the balloon's radius is increasing. So we want to find dr dt. Okay. We changed this to radius just now. So we're just only talking about volume and radius in this diagram with respect to time. So volume, radius. Okay, so yeah, in this diagram we've only got volume and radius. Is there an equation that we know that can help us relate the volume of a sphere with its radius? You tell me. Yeah, there is. You remember from like high school geometry? You had this formula. Volume is equal to 4/3 times pi r cubed. So volume is equal to 4/3 times pi times radius cubed. Okay. So we've got dV dt. How can we use that over here though? There's no t in this equation. And also we need to find dr dt. That's not here either. Okay. Well, you're going to have to introduce them by taking d dt of both sides of this equation. Right? If I take d dt of both sides of this equation, then I'm going to get dv dt is equal to, so we're taking the derivative of this with respect to t. If you need a refresher on how to do these, I have a video that explains how to do these equations. Yeah. Okay, but d dt of this, so I need to move the 3 in front. So it's going to be 3 times this times r squared, because I need to subtract 1 from here. And then I also need to include what over here? dr dt. Okay, so what did we just do? Basically, we had no way to use dv dt, and there's no t here, right? So we couldn't use this, and we can't find this, right? Because both of these have t in them. But once we took d dt of both sides of the equation, then we had dv dt, we have dr dt now. Okay, now if you've watched my previous video, you should be able to finish off this problem on your own. So don't look at the previous video. Try to recreate the solution here as practice on your own. If you didn't watch the previous video, go watch it. I highly recommend watching it before doing any related rates problem. But yeah, we'll work it out here again. All right, I'll give you a second. Okay, so what does this simplify as? 3 times 4/3 is 4. So 4 pi times r squared times dr dt. Now, what did we say that r was again? R is 1. Okay. So dv dt is equal to 4 pi times 1 squared times dr dt. Okay. So what did we just do? We just did step 3. Step 3 is to step 3. Once you have the equation, take the derivative of the equation, usually with respect to time. And that's what we did here. Yeah, right here. Then we started plugging stuff in. We plugged in the radius, and now we're going to plug in dv dt. Okay, so 2 pi equals 4 pi times 1 squared, which is just 1, dr dt. And multiplying by 1, oops, 4 pi. Multiplying by 1, that's just 4 pi, so just... This is the same thing as 4 pi dr dt. All right. And then step 4 is to isolate the rate of change that the problem asks for. Okay. So that's step 3. Step 4. Isolate the rate of change the problem asks for. So how do we get this by itself? What do we need to divide by on both sides of the equation? Divide by 4 pi. Okay. So 2 pi divided by 4 pi. All right, whatever I write down on this sheet, you don't have to write down when showing your work. I'm just doing this to elaborate on a few things. But to simplify this fraction and cross out the pi's, and 2/4 simplifies as 1/2 because I can divide out 2. All right. So if I divide by 4 pi on both sides of this equation, I'm going to get 1/2 is equal to dr dt. Okay. Now, you also need to include units here, right? Because this is a word problem. Okay, so that's step 4. Step 5. Step 5 is to include units. Okay, so 1/2. What is the radius measured in? If we're measuring the volume in cubic centimeters, what would we measure the radius in? So, volume cubic centimeters. So this gets raised to the power of 3 because spheres are 3-dimensional objects. How many dimensions are there to a radius, or to a line segment? This is 1-dimensional. Okay. So that means it should be in centimeters. It should be in centimeters per second. This is your answer. But yeah, these are the steps to solving related rates problems.